All right, now the converse of the Pythagorean theorem. Converse just means that we're going to do it backwards, okay? So the converse, remember the Pythagorean theorem, right? All right, there's our Pythagorean theorem at the bottom. If you have a right triangle, then leg to the power of 2 plus leg to the power of 2 equals hypotenuse to the power of 2. Well, the converse is just going to switch the if and then statements. So it's still an if-then statement, still conditional. It's just backwards, right? If you found that a leg to the power of 2 and another leg to the power of 2, and you added those together, those two legs to the power of 2's squared, then as it turns out, you'd find it would equal the hypotenuse to the power of 2. It's a long word. Then you have a right triangle. Use a symbol for that triangle because it's a big word. All right, see how that switches the if-then statement? If you find that you had 3 side lengths, then the leg to the power of 2 plus the other leg to the power of 2 equal the longest value to the power of 2, then you'd have a right triangle. So that's something else that you need to understand about these right triangles is the longest side is always the hypotenuse. That's going to be crucial because in the following problems, they're not going to give us a picture of a triangle. They're only going to give us 3 side lengths, and they're going to say, does it make a right triangle? Well, that's where we use the converse of the Pythagorean theorem for that. All right, so will these 3 side lengths make a right triangle? It's wording it different, but that's pretty much saying the same thing. Will these 3 side lengths make a right triangle? Now, do remember, and sometimes they don't always put these in order, so you have to look at these and think, well, which is the longest side? Because the longest of the 3 values, the biggest of the 3 values, is always the hypotenuse, okay? Which means in this case, I would say that 11 and 60 are the 2 shorter sides, and 61 is the C value, all right? So the 2 legs we know are 11 and 60. We're going to square those and add them together and see if it equals the hypotenuse, which is 61, to the power of 2. So we don't know if this is true yet, but we're trying to find out. So I'm going to put a question mark over the equal sign. Well, I put an equal sign right there too. That's supposed to be plus. So I can put this into the calculator now. Okay, 11 to the power of 2, that's 121. 60 to the power of 2 is 33,600. I don't know what 61 to the power of 2 is, though. Let's put it in the calculator and find out. 3,721. There we go. Now, if I add the 2 legs together, I should get that green value, 3,721. And when I do, 121 plus 3,600, yeah, 3,721. So again, this is more of a question. Does that equal 3,721? Because if it does, then this would be a right triangle. That's true. Right there, okay? Now, if by chance we added the 2 legs together as squares, and we got not the same as the green value, then we'd say it is not a right triangle. It would make something else. Perhaps not even a triangle. We don't even know, nor do we care. Because we only want to know if it will make a right triangle. That is all. So the answer, the final answer on this one is just yes.